Hello. So, today we will see the algorithm for finding the median in more details. We discussed the algorithm in the previous class. We will fill in the details and do the analysis of the algorithm today. So, in this problem the input is a set S of numbers which we call as A1, A2, An. We may assume that n is an odd number, so that the median is the n plus 1 by 2th element, and the output will be the median of S. Okay. So, our algorithm, the basic steps are as follows. First step is randomly choose n raised to 3 by 4 elements of S to form the multiset, let us say R. Okay. We could have just chosen n raised to 3 by 4 elements without replacement, but here we do it with replacement because that makes the analysis simpler. And the second step is sort R and determine two numbers D and U. So, D is the half n raised to 3 by 4 minus root nth element of R, and U is the half n raised to 3 by 4 plus root nth element of R. Okay. So, we have randomly picked a set which we call as R. We sort the elements of R, and if this was our collection R, the middle element, let us say that is the median of R, that is the n by n raised to, there are n raised to 3 by 4 elements. So, this is the n raised to 3 by 4 by 2th element. We go left side by a distance root n, and we go right to a distance root n, and pick the elements at these locations. That will be our D and U. This is our set R. Now, based on this D and U, we are going to split the entire array S into 3 parts. So, that will be our third step. Split S into A, B and C, where A is the elements of S which are smaller than D, and C is a set of elements which are larger than D, and B is the in between elements of S which are between D and U. Okay, so, C is the set of elements which are larger than U. So, we can think of this as, let us say if this was our entire set S, this side would contain all the elements smaller than D, and this side, so these region would consist of all the elements which are greater than U. So, this is our point D and this is our point U, and these are the in between elements, that would be B. Okay. Now, once this D and U are determined, what we will do is we will run some checks to ensure that the median is in B and B is small enough. So, if size of A is greater than n by 2 or size of C is greater than n by 2 or size of B is greater than 4 times n raised to 3 by 4. Okay. This is the size of B is some parameter that we have chosen so that the algorithm works nicely and the analysis goes through smoothly. Okay. So, if any of these condition happens, then we will say we will just quit. Okay. We will not output a median, we will just say that we have failed. What we have to do later on is that we will, when we analyze the algorithm, we will show that the probability of such a thing happening is small. So, if this is not the case, that means A is not greater than n by 2, size of A is not greater than n by 2 and B is not greater than, C is not greater than n by 2 and B is smaller than 4 n raised to 3 by 4. If this is the case, then what we will do is we will find the median. So, in this case the median will clearly lie in B because A contains less than n by 2 elements. So, if you look at A, if you look at S in the sorted order, the median will be right at the middle. The elements which are smaller than D, that will be less than n by 2, there are less than n by 2 elements of that kind, and the elements which are larger than U, they are also less than n by 2. Okay. So, this is less than n by 2, this is less than n by 2. Okay. So, median lies in the small region. Okay. So, then, so based on the size of A, we can determine the median. How do we do that? So, suppose LD is the size, so LD is equal to size of A, then if you find the n by 2 minus LDth element of B, that will be our median. So, already the elements in A are known to be smaller than median, okay, and they are all smaller than D. So, D's position is LD. Now, what we are interested in is the n by second element, the middle element in the entire array. So, that can be determined by going n by 2 minus L. So, the element which is at that position in the array B. So, I will just write this as determine the median by examining B. That means, go look in B, find the n by 2 minus LDth element, that will be the median. Now, how do we find the n by 2 minus LDth element in B? We could just sort B. B is guaranteed to be a small set, it contains at most 4 times n raised to 3 by 4 elements. Therefore, we can completely sort the array, and after sorting we can determine the element inside the element at any position inside B. Okay. So, that is our median algorithm. Okay. Now, first let us see that this algorithm works in linear time. The first step of choosing n raised to 3 by 4 elements, that can of course be done in order n time, and since R consists of only n raised to 3 by 4 elements, okay, we can just use an n log n sorting algorithm, and since the total number of elements is bounded by is exactly equal to n raised to 3 by 4, this step will take only n raised to 3 by 4 log n raised to 3 by 4. So, that is going to be the time taken by step 2, that is going to be less than order of n. And then the splitting of, once you have determined d and u, splitting of the entire array into 3 parts will take no more than linear time. Okay. So, each element after examining we can determine for any element inside S whether it falls in A or B or C. So, this can be done in order of n time, and the size of this sets also can be determined in linear time. And once we have done that, since B is guaranteed to be a small set, we can just sort the entire collection B and find the median of the complete set. So, the algorithm clearly runs in linear time. Okay. Okay. So, first the algorithm runs in linear time. It takes no more than O(n) steps. We need to compute the error probability. So, what is the probability that this algorithm fails to produce an answer. Okay. So, this algorithm can fail if three conditions happen. If any of these 3 conditions happen, the first condition, size of A greater than n by 2. So, this we will call it as event 1. The second condition was size of B greater than n by 2, that is going to be event 2, and the third condition is, the second condition was size of C greater than n by 2, and the third condition is size of B is greater than 4 n raised to 3 by 4, and this we will call as event E3. And what we are interested in is the probability of E1 union E2 union E3, and we will show that this is less than, say, something like 1 by n raised to 1 by 4. So, this is what we will show in our analysis. If we can show this, that would mean that if n is, say, something like, if you had to sort 10,000 numbers, there is at least a 90% guarantee that the algorithm will work correctly. Okay. So, for n equals 1000, this gives 90% probability of success. Now, observe that if you are given an element and you have to find the median, you have to check whether it is a median, that can of course be done in linear time. Okay. In any case, our algorithm always gives an answer which is a correct answer, or it just fails and does not give any answer. So, we could just run the algorithm multiple times. Let us say we run the algorithm 3 times, and if it gave an answer, the median that it gave in all the 3 different trials will be same. Okay. There is of course a small 10% chance that the algorithm will fail to produce an answer, but that happens with only 1 by 10 probability. So, if you do it 3 times, the probability of failure becomes no more than 1 by 10 into 1 by 10 into 1 by 10. Okay. So, that is going to be a 0.1% error. Okay. So, just by, we had a linear time algorithm, we just ran it 3 times, and ensured that we have 99.9% accuracy. Okay. You can repeat it more times and get significantly higher. I mean, whatever is the probability of success that you are interested in, you can get that by choosing the number of times you have to run the algorithm. Another way is to keep on running the algorithm till it finds an answer. The first time it finds an answer, first time it runs without quitting, that answer can be declared as the median. Now, in this algorithm, there is a small chance that the algorithm will continue running for a long time. We can analyze what is the expected running time of this modified algorithm and show that the modified algorithm also will run in linear time. Okay. All this is if we prove this particular claim, that probability of error is less than 1 by n raised to 1 by 4. So, how do we, let us see how do we prove that. So, first let us look at this particular event E1, namely size of A greater than n by 2. The event E2 is a symmetric event. So, the probability that we compute in case 1 can be directly used for the case 2. So, let us just draw the running of the algorithm in a different manner. So, this is our set R. This is the set R that we had randomly sampled, and let us say this was our original set. S. So, S had n elements and R had n raised to 3 by 4 elements. So, let us imagine this S to be a, let us imagine that S has a sorted collection and draw the entire thing. So, from this collection we are drawing the set R without with replacement. Okay. So, let us say this is the middle position, that is the n raised to 3 by 4 by 2th position, and if you go root n towards this direction, you will get your D, this is the position D, and if you go root n towards this direction, what you will get is your U. Now, this D and U are elements of the original set. Where do they lie? If we had imagined S as a sorted collection, we want to figure out where does this D lie. So, if this was the middle portion of S, if this element here denotes the median, if your D, so D is a random element, in the sense D is determined on the basis of the elements that we have sampled, that is a random sample. So, once the random sample is fixed, your D has a particular value. So, now we want to look at that particular random value D and figure out where would it be in the entire set S. If A is greater than n by 2, then this D is essentially falling inside the right side of this diagram. Okay. So, we want to determine what is the probability of that happening. Okay. So, if D is here, then what can we tell about all these elements to the right of D? So, I will write it as an observation. All the sampled elements in R to the right of D are greater than the median. Okay. Therefore, at most n raised to 3 by 4 by 2 minus root n elements can be smaller than the median. Okay. So, whenever the event E1 happens, the number of sampled elements which are smaller than the median is going to be strictly less than this quantity over here. Okay, I will repeat that. Whenever the event E1 occurs, the number of elements that we had randomly sampled, which are going to be smaller than the median, is going to be at most n raised to 3 by 4 by 2 minus root n. Okay. We will show that that happens with very small probability. Okay. So, let us set things up. Let y be a random variable which counts So, let y be a random variable such that y is equal to number of sampled elements which are less than the median. Okay. We know that the expected value of y should be approximately n by 2, sorry, n raised to 3 by 4 by 2. I am writing approximately because I do not want to bother about even and odd. Okay. So, when you randomly sample an element, the probability that the randomly sampled element is less than the median is half, greater than the median is also half, I mean approximately. So, there is a half plus 1 by n depending upon whether you include the median or not, but we can say that it is approximately 1 by 2. So, the expected value of y is going to be n raised to 3 by 4 by 2. Now, when the event E1 occurs, what happens is the random variable y has value much smaller than its expected value. It deviates from the expected value. Okay. For the sample that we have chosen, the value of y happens to be smaller than the expected value of y by an amount root 2. Okay. So, we will write this down. When E1 occurs, when the event E1 occurs, y is less than n raised to 3 by 4 by 2 minus root n. So, probability of E1 is going to be less than the probability that y is less than n raised to 3 by 4 by 2 minus root n, and this probability we will determine. So, this event y less than n raised to 4 by 2 minus root n, the probability of that event we will determine. Okay. So, how do we find that? So, we will use Chebyshev inequality. So, Chebyshev inequality says that probability that a random variable deviates from its mean, so x minus expectation of x, greater than a is going to be less than variance of x divided by a square. Okay. So, we need to look at this. So, we need to look at this particular event y greater than n raised to 3 by 4 by 2 minus root n. Okay. So, this we can, so probability of this is surely less than the probability that y minus expectation of y greater than root n. Okay. Whenever y minus expectation of y is greater than root n, whenever y is greater than n raised to 3 by 4 by 2 minus root n, y minus expectation of y is going to be greater than root n. Okay. So, this probability is going to be less than or equal to variance of y divided by a square, a is root n, so that will be n. So, now we need to determine what is the variance of y. So, what again was our y? Y is the number of sampled elements which are less than median. Okay. So, y we can write it as y1 plus y2 plus y k, where k is the number of elements that we have sampled. Okay. So, k equals n raised to 3 by 4. Okay. And these samples are independent samples, because here is where the assumption that we had sampled with replacements come handy. So, when you sample with replacement, all these y1, y2, yk are all independent of each other, and probability that, so what are these y1? Y1s are our indicator random variable, yi equals 1 if the ith sample less than median. Now, the probability of this happening will be half, be minus 1 by n, or so we will just assume it to be half, that just maybe there is a 1 by n term depending upon whether you pick median or not, but half is a reasonably good approximation. It will you can replace it with one, you can correct for the middle element, but we will just do the calculation with half. Okay. So, this happens with probability y equals 1 with probability, yi equals 1 with probability half. Okay. So, expectation of yi equals half and variance of yi equals 1 by 4. Okay. And in this case, when you add up the random variables, their variances just gets added up. So, variance of y is equal to number of samples, that is k divided by 4. Okay. So, basically it will be 1 by 4 plus 1 by 4, there will be up to k terms. So, that is k by 4, that is equal to n raised to 3 by 4 by 4. Okay. So, we can substitute that here. So, variance of y is going to be n raised to 3 by 4 divided by 4 divided by n, that is going to be 1 by 4 n raised to 1 by 4. So, this is a probability of E1, okay, where E1 was the event that the element D that we had found out by sampling is going to be greater than, it is going to lie towards the right of the median. Okay. So, the probability of that bad event happening, we have bounded it by 1 by 4 n raised to 1 by 4. Similarly, E2 will also happen with, so probability of E2 will also be less than n raised to minus 1 by 4 by 4. Okay. So, in that the analysis will be slightly different. So, if you take U, now U has to fall in this side to the left of S, that is when size C is going to be greater than n by 2, but when that happens, the number of elements which are greater than the median is at most n raised to 3 by 4 by 2 minus root n. That is, if u falls here on this, on the left side of the median, then all the elements to the left of u in R are going to be less than the median. So, only these n raised to 3 by 4 by 2 minus root n elements stand a chance of being greater than median. So, the maximum number of elements which are greater than the median in the sampling of R is going to be bounded by n raised to 3 by 4 by 2 minus root n. Okay. So, then the analysis is essentially same, and we will get the probability of E2 to be less than n raised to minus 1 by 4 by 4. Now, we need to look at this event of probability of E3. Okay. So, E3 was this event. So, E3 is the event that size of B is greater than 4 n raised to 3 by 4. Okay. So, once we had split the entire set into 3 parts, the middle element being greater than n raised to 4 times n raised to 3 by 4, what is the probability of that happening? We will show that that probability is also small. Okay. We will look at this set B, okay, and if 4 n raised to 3 by 4 elements are there in B, we can say that either half of those elements are going to be greater than the median, or half of those elements are going to be less than the median. Okay. So, we will split it into 2 events. So, let us say E31 is the event that 2 n raised to 3 by 4 elements of B are greater than the median, and the next event is 2 n raised to 3 by 4 elements of B are less than the median. Okay. So, what is the probability of, so we need to determine, so whenever B has 4 n raised to 3 by 4, either 2 n raised to 3 by 4 elements in that will be greater than the median, or 2 n raised to 3 by 4 elements of B will be less than the median. So, probability of E1, E31 union E32 is surely less than probability of E31 plus probability of E32, and by symmetry we can say that both these probability will be same. So, this is equal to twice the probability of E31. So, we will determine the probability of E31 and show that that is also significantly small. Therefore, the probability of E3 is going to be less than some quantity. We will show that this is going to be less than, let us say, n raised to minus 1 by 4 by 2. So, now we look more closely at the third event, which is that the elements which are in between D and U is larger than 4 n by 3, 4 times n raised to 3 by 4. Okay. So, this was our diagram. If we looked at the set S, this is its median. Now, these were the set A and these were the set C. This was the set A, this B, and this is C. A is all those elements which are smaller than D, and C is all those elements which are larger than U. B is the in between elements. We want our algorithm will work correctly only when B is small. Small for us is 4 times n raised to 3 by 4. We want to analyze what is the probability of this not happening. That is, what is the probability that number of elements which are in between D and U is going to be greater than 4 n by 3. Now, when this happens, and if the middle third has larger than 4n raised to 3 by 4 elements, we can just simply say that at least, either half of the elements are larger than median or half of the elements are smaller than the median. Okay. So, we will look at these two sub events and compute their probability, and that probability will be a bound on the probability of E3. Okay. So, we are interested in this probability that E3 occurs. Okay. So, E3 is the event that number of elements in B which are larger than the median is greater than 2n raised to 3 by 4. Okay. So, how do we compute this? Okay. So, if the middle third contains more than 4n raised to 3 by 4, the first case was when half of those elements are greater than the median. If half of them are greater than median, then we can say that the position u comes after all these 2n raised to 3 by 4 elements. So, the position of u in the array S, in the input array, is at an index greater than n by 2 plus 2 times n raised to 3 by 4. Okay, because u is appearing after all the elements in B, and in B we are assuming that there are at least 2 times n raised to 3 by 4 elements which are larger than the median. If there are 2 times n raised to 3 by 4 elements larger than the median, the position of u is after all these larger elements, and therefore, it is at an index which is greater than n by 2 raised to n by 2 plus 2 times n raised to 3 by 4. This is the case E31. Okay. We need to compute the probability of this happening. So, probability of E31 is surely less than the probability of u's position being after n by 2 plus 2 times n raised to 3 by 4. Now, when this happens, that is u's position is after n by 2 raised to n by 2 plus 2 times n raised to 3 by 4, let us look at the elements that we had randomly sampled. In the elements that we had randomly sampled, this is the position of u, that is, look at the middle of R, from there go right by a length root n, and at that position whatever element was there, that was our u. Since u itself is greater than the n by 2 plus 2 n raised to 3 by 4th element, all the elements to the right of u will also be greater than these elements. So, all these elements, okay, these will all be big. Okay. Big here means greater than the, if we call this as t, greater than the tth element of A. Okay. And we have n raised to 3 by 4 by 2 minus root n big elements. Okay. So, in other words, when the event E31 happens, we are guaranteed that our sample contains lot of, here lot of means n by n raised to 3 by 4 by 2 minus root n. So, our sample contains lot of large numbers. Large numbers being the numbers which are greater than the number at the tth position, where t is this particular number. We will show that the probability of that is small, that is the probability of having large number of large elements when we randomly sample, that is going to be small. So, let us compute that probability. We will set up indicator random variables. So, let us say x denote the number of elements in R that are greater than the tth element of S. Okay. So, this is a random variable x. X we can write as x is equal to x1 plus x2 plus xk, where k is number of samples, which was n raised to 3 by 4. Okay. And we want to compute the probability that x is greater than, okay. So, here we have at least these many large elements. Okay. So, we will compute the probability that n raised to 3 by 4 minus 2 minus root n big elements are present. So, this is by Markov so we will apply Chebyshev's inequality here. So, this is less than the probability that x minus n raised to 3 by 4 by 2 mod of this is greater than root n or equal to root n. Okay. So, by Chebyshev's inequality, this is going to be less than variance of x divided by root n square, that is n. Okay. So, we need to compute variance of this random variable, that is going to be the, so variance of x is going to be variance of x1 plus x2, okay. So, that is sum over I variance of xi, and the variance of each of these xi's will be same, and what is that going to be? Okay. So, xi is going to be 1. So, what are these indicator random variables? This is xi is equal to 1 when ith sample in R is greater than n by 2 plus 2 n raised to 3 by 4. Okay, and this is 0 otherwise. Okay. So, probability that xi equals 1 is equal to, there are a total of n samples, out of that the numbers which are greater than this is going to be n by 2 minus 2 n raised to 3 by 4. If you add this, sum is n. So, this divided by n is the probability that xi equals 1. So, that is going to be equal to half minus 2 n raised to 1 by 4. Okay. So, therefore, so this if we think of it as p, variance of xi is going to be pq. Okay. For a geometric for a random variable which takes value 0 and 1 with probability p, its variance is going to be p times 1 minus p. Okay. So, that is going to be equal to, so variance of xi is going to be half minus n raised to 1 by 4 into half plus n raised to 1 by 4, that is equal to half 1/4 minus, so this is n raised to minus 1 by 4, so n raised to minus half. Okay. So, you can say that this is approximately 1/4. So, total variance of x is that will not suffice. So, when the set R has more than 4 n raised to 3 by 4 elements, we look at the sub event that half of them are greater than the median. If half of them are greater than the median, then the element u from this sampled elements is going to be at least these are greater than the 2 n raised to 3 by 4 sampled elements. So, u is going to be at least as large as the n by 2 plus 2 times n raised to 3 by 4th element of S. Okay, so, we will call this as T. So, u is going to be at least as large as the Tth element of S. Okay. Once again, this is happening because we assumed that 2 n raised to 3 by 4 elements are larger than the median. So, in our sample these many elements are larger than the median. If these many elements are larger than the, we assume that in our sample when we split the set S on the basis of the sampled elements, the middle portion contained large number of large elements, large number of elements which are in between D and U. So, when there are lots of elements between D and U, and if we assume that half of those elements are greater than U, are greater than the median, then since U comes after all these elements, U is going to be greater than n by 2 plus 2 times n raised to 3 by 4th element of S. So, this was our D. So, in our set S, this was our D and this was our U, and if there are large number of elements, that is 2 n raised to 3 by 4 elements which are greater than the median, then U is clearly greater than the Tth element of S. Median is the n by 2, the element at n by 2 position, and 2 times 3 n by 4 elements are already greater in this middle portion. So, U comes certainly after this position. Therefore, if we look our samples, we can claim that at least these many elements are greater than the number at the Tth position. So, at least T elements, so let us call this as P, at least P elements are larger than the Tth element of S. If we pick one element, what is the probability that it is greater than the Tth element? Well, that is going to be, so probability that a sample element is greater than T, that is going to be equal to n minus T by T. Okay. So, now we have picked n raised to 3 by 4 samples. We need to estimate what is the probability that P of those samples are greater than T. So, we will compute that. So, let us say x denotes the random variable. So, x is the number of elements in R which are greater than t. So, x we will write as x 1 plus x 2 plus x k, where k is going to be equal to n raised to 3 by 4, and x 1 is equal to or any x I is equal to 1 if the ith sample is greater than t, and probability that x I is equal, and this is equal to 0 otherwise, probability that x I is equal to 1 is going to be n minus t by n, that is going to be equal to n minus n by 2 plus 2 n raised to 3 by 4, that is the value of t divided by n, that is equal to n by 2 minus 2 n raised to 3 by 4. Therefore, expectation of x I will be this divided by n. So, that is going to be half minus 2 by n raised to 1 by 4. So, expectation of x I is half minus 2 by n raised to 1 by 4. So, expectation of x will be just the sum of these. So, that will be n raised to 3 by 4 into 1 by 2 minus 2 n raised to 1 by 4, that is going to be n raised to 3 by 4 by 2 minus 2 root n, okay, n raised to 3 by 4 by n raised to 1 by 4, that is root n. Okay. And variance of x is going to be the sum of the variances, these are independent random variables. So, that will be sum over I variance of x I, that is going to be again n raised to 3 by 4 times the individual variance, that is going to be, this is p, then the overall then the variance of this is going to be p into 1 minus p, that is going to be 1 by 2 the whole square plus minus 4 by root n. So, that is going to be, so variance is going to be n raised to 3 by 4 by 4 minus 4 by minus 4 into n raised to 1 by 4. Okay. Now, so we need to look at this particular probability. Probability that x is greater than n raised to 3 by 4 by 2 minus root n. Okay. We can write this as probability that x minus n raised to 3 by 4 by 2 minus 2 root n So, this is going to be expectation of x plus, so greater than plus 2 root n minus root n. Okay. Just rearrange the expression. So, that is the probability that x minus e of x being greater than root n. So, this probability by Chebyshev bounds we can say that it is going to be less than variance of x divided by a square, a is n here. So, that is going to be less than n raised to 3 by 4 by 4 minus 4 n raised to 1 by 4 by n. Okay. So, that is clearly less than n raised to 3 by 4 by 4 n. Okay. So, we know that probability of the bad event, that is E31 is less than 4 n raised to 3 by 4 by n. So, this is equal to 4 by n raised to 1 by 4. Similarly, we can show that probability of E32 is also less than 4 by n raised to 1 by 4. So, this is less than 4 by n raised to 1 by 4. So, together, so the 4 is in the denominator. So, we can, so this is going to be less than one by 4 n raised to 1 by 4. So, total probability, so probability of E3 is going to be less than half n raised to 1 by 4. So, probability of E1 and probability of E2, they were also less than one by 4 to the power n raised to 1 by 4, this is less than 1 by 4 n raised to 1 by 4. So, together probability of bad event is going to be less than 1 by n raised to 1 by 4. Okay. So, the probability of success is 1 minus 1 by n raised to 1 by 4. Okay. So, that is a reasonable success probability.